In this video, let us learn about what is the importance of rectifiers in the electronic circuits. Now moving on to the topics, first let us see some introduction to the rectifier. Generally, in large number of electronic circuits, we require the DC voltage for the operation of the circuit. And for converting the AC voltage or the AC current into DC voltage or the DC current, we make use of a device which is called as a PN junction diode. And a PN junction diode allows the electric current in only forward bias condition and blocks the electric current in the reverse bias condition. That's why in simple words we can say that the PN junction diode allows the electric current in only one direction. And this unique property of the diode allows it to act as an rectifier. Now let us see how we can define the rectifier. A rectifier is an electronic device that converts an alternating current into a pulsating DC current by using one or more PN junction diodes. So if you see here, this is a power transformer to which the AC input signal is applied, and this AC input signal is transferred to the secondary windings of the power transformer, and it is given as an input to the diode rectifier. This is a diode rectifier. And this diode rectifier converts this alternating current into the pulsating DC current. So if you see here, this is the output for the half wave rectifier, whereas this is the output for the full wave rectifier. So the forward bias and the reverse bias voltage which is applied to the diode is nothing but a DC voltage, and a DC voltage produces a current which always to flow in one direction, that is either from forward direction or from the backward direction. But an AC voltage produces a current which always reverses its direction many times in a second, that is from forward to the backward direction or from backward to the forward direction. Hence, the AC voltage or the AC current is often represented by a sinusoidal waveform, whereas the DC current is represented by a straight horizontal line. And the rectifier circuit consists of an rectifying element, that is PN junction diode, and a resistive load. So if you see here, this is the rectifying element which is the PN junction diode, and this is the resistive load which is RL. And the rectifier circuit is applied with an input AC voltage source with a frequency of 50 Hz. So this is a 50 Hz frequency with an input AC signal applied to the rectifier. And the rectifier makes use of a step-down transformer which decides the peak value of the voltage. So if you see here, this is the step-down transformer with the primary windings and the secondary windings. And this decides the peak value of the voltage with N1 as the primary number of turns. So this is the N1. And N2 as the secondary number of turns. This is the N2. And if EPM is the peak value of the primary voltage and ESM is the peak value of the secondary voltage, then the ratio of number of turns N2 by number of turns N1 is equal to ESM by EPM. And as the ESM is a sinusoidal waveform, the value of ES is equal to ESM into sin omega t, where the value of omega is equal to 2 pi f, in which f represents the supply frequency. And in the sinusoidal waveform, the upper half cycle represents a positive half cycle and the lower half cycle represents a negative half cycle. So if you see here, this is the sinusoidal waveform in which the upper half is representing the positive peak, whereas the lower half cycle is representing the negative peak. And the positive half cycle of the AC voltage is analogous to the forward bias DC voltage, and the negative half cycle of the AC voltage is analogous to the reverse bias DC voltage. And the alternating current starts from the zero and grows to a peak forward current or peak positive current. So that's why if you see, the current is initially starting from the point 0 and it is reaching to the positive peak of the forward current. And the positive peak of the sinusoidal waveform represents the maximum or the peak forward current. And after reaching the peak forward current, it starts decreasing and reaches to 0. So after reaching this peak point, then it slowly starts to decrease and reach the point 0 again. So after a short period, the alternating current starts increasing in the reverse or the negative direction and grows to the peak reverse current or the peak negative current. So after reaching the point 0, it starts increasing in the reverse or the negative direction and it reaches the negative peak current. The negative peak current of the sinusoidal waveform represents the maximum peak or the peak reverse current, and after reaching the peak reverse current, it starts decreasing and reaches the point 0 again. So after reaching the peak reverse current, it again starts decreasing to the point 0. Likewise, the alternating current continuously changes its direction in a short period. So that's why during the positive half cycle, the diode allows the current, and during the negative half cycle, the diode blocks the current. Thus, the electric current flows through the diode only during the positive half cycle of the AC current. And the electric current doesn't flow through the diode during the negative half cycle of the AC current. So finally, the PN junction diode acts as a rectifier by converting the AC current into the pulsating DC current. So this is how the PN junction diode is acting as a rectifier for converting the AC current into the pulsating DC current. Finally, there is a quiz for testing your knowledge. Click on the link below so that you will be directed to the Google form quiz. Hope you like this video and understand the concept of how the rectifiers are used in the electronic circuits.